All right, hello everyone. So these are the notes for tomorrow, which is Wednesday, that we were supposed to have, but because school is closed, we're not able to do that. However, I did not want you all to miss. So these are the notes. Hopefully you're able to print them off because I did attach a PDF of the notes. If not, then you can just write them by hand, or if you know you can print it off at a later time, you can write down the fill in the blanks and then go back to it. Whatever you have to do, just make sure you take good notes and write them down carefully. Okay, so I don't know how many videos, it'll probably be 2 or 3 because I don't like to go past 10 minutes at most on a video, and it hopefully won't take that long. So let's get started. On Monday, we talked about marginal cost, and I just wanted to do another example to make sure we were clear on what's going on. So here we have a company manufactures automatic transmissions for cars. The total weekly cost in dollars of producing X transmissions is given by this formula right here. C of X, which is our cost function, equals 50,000 plus 600X minus 0.75X squared. So C of X, like I said on Monday, it's our cost function, but it's the total cost of producing X items. So it's not the cost of producing a single, hope you can read my writing, item. Okay, it's the total cost. So if we were talking about 100 items, C of 100 would be the cost of producing 100 items, not a single item. So if we want to find the cost of producing a single item, we use the difference of the two successive values. So this is what we talked about in terms of C of X, the exact cost of producing, if it's, say if it's a 100, if you want to know 101. So the cost of producing that extra one item would equal C of X plus 1 minus C of X. Okay. And so if you think about that, it makes sense because this tells you, so C of X plus 1. So again, let's say we wanted to know how much it costs to produce the 101st item. Well, to find the exact cost, we take the cost of C of 101, which would be the cost of producing 101 items, so the total, minus C of 100, which is the cost of producing 100 items. So if you take the cost of producing 101 items and subtract it from the cost of producing 100 items, then that gives you the cost of that one item. And so that's what C of X. I just want to make sure we're clear on that. And so that's the exact cost function. And C prime of X is an estimate of the marginal cost. Okay. So now let's look at, so find the exact cost of producing the 201st item. Okay. So we're going to use the exact cost. We're going to use C of X equals C of X plus 1 minus C of X. And so in this example, X plus 1 is 201, okay, minus C of 200. And that's going to give us the cost of producing that 201st item, okay, that extra item, okay. And I want you to do the math on here, but you should end up, your final answer should be $299.25. Okay. Okay, so now for part B, we want to estimate the marginal cost at a production level of 200 tanks per week. Okay, so now for our estimate, we think derivative. So C prime of X, and if you look back on this page, you see that the derivative of C prime of X will be C 600 minus 0.75 times 2, which is 1.5. X. So make sure you check these numbers too, to make sure I didn't make any mistakes, okay? And so then we just evaluate this at 500, and we should get 300. Okay. So there we have the estimate of our marginal cost and the exact cost of producing 201st item. Okay, and just to reinforce what these two A and B are saying, in finding the exact cost, so in using our cost C of X function, when we take C of X plus 1 minus C of X, that tells us how much it costs to produce one additional item. Okay, that's the same, or it's similar, as we can see, because so that's $299.25. Now, when we estimate the marginal cost at a production level of 200, so when we take that derivative, that's given us the cost of adding one additional item. So again, once you take the derivative of your cost function, then you know for adding one additional item, that's the cost of adding one additional item. And I see, hopefully someone caught my mistake. This should be 200 and not 500. Okay, so now we have the last thing in 3.4 that I wanted to talk about. Actually, there's another thing, but I'll bring that back up in 3.5 is linear motion. So here we have S is equal to position. That's your position function. So that's your f of x function. And then the derivative of S with respect to time, time is going to be V, which represents your instantaneous velocity. So again, you can think of the position function, that's sort of the average, that's your f of x. And then when you take the derivative, that gives you your velocity. And velocity represents direction. So that means it can be positive or negative. It's the direction of motion. And speed is the absolute value of velocity. So speed can never be negative because we can't go back in time, right? But, unless you're watching Back to the Future. Okay, sorry. But velocity can be positive or negative. Okay, so now let's look at a function, and I have about 3 minutes left on this video. So S is equal, again, that's our position. So let S equals f of t, which equals t cubed minus 6t squared plus 9t, where t is in seconds and S is in meters. Part A says find the velocity at time t. Okay, so the velocity velocity equals f prime of t. Okay, which equals, so the derivative, which also, so we're clear, this equals the derivative of S with respect to t. And so that's 3t squared minus 12t plus 9. Okay, and so part B says find the velocity after 2 seconds and after 4 seconds. So I'm going to have you guys do that on your own. So you need to finish on your own. Don't write that on your paper because you're going to lose space, okay? All right, so you need to finish that. C, when is the particle at rest? So thinking of, we're talking about a position function and thinking of linear motion. So a particle is at rest when it looks like it's a horizontal line. When the tangent is horizontal, it's a horizontal line. So the tangent is horizontal, meaning the derivative is equal to 0. Well, in terms of a position function, our derivative is velocity. So we need to set v of t equal to 0 and solve for t. I don't know what I did. Okay, and solve for t. And I'm going to have you finish that one. I think you guys can finish that on your own. So finish that on your own. And the last thing that I want to talk about is when is the particle moving forward? That is in the positive direction. So again, when we're talking about direction, remember velocity represents direction of motion. So if we're moving in the forward direction, then we want to know when is velocity greater than 0. And I'm going to stop this video here and start another one. So think about that. When is velocity greater than 0 for our function we're talking about, for our velocity function, which is v of t equals, what was our velocity function? 3t squared minus 12t plus 9.